Okay, thank you. Separation techniques, right? Still under properties of substances topic, right? Our last theory lesson, we talked about the differences between suspensions and solutions. We talked about the difference between soluble and insoluble. Yeah? We talked about the differences between concentrated, dilute, and saturated. Right. And so when we talk about either insoluble substances or suspensions or even solutions, they're all types of mixtures. And what we're going to discuss over the next couple of lessons is how do we separate those substances into something that is pure, right? Remembering that a pure substance is a substance that is all the same type. Yes?
Are we only solid substances or soluble substances?
Insoluble. Yeah. Okay. So what I'm going to focus on today is this first section, looking at the 5 techniques.
What was I thinking? I forgot what I was thinking.
Ask me later.
The right page.
Yep, that's towards the end. We'll cover that next lesson.
Wouldn't every solid be soluble apart from temperature?
Everything is soluble to an extent, yeah?
Yeah.
But the level of that extent can be very, very small, and we regard those very, very small amounts as effectively insoluble in water. Okay, moving on. So we're going to focus on these first 5 techniques.
I thought you
Yeah. Oh, I meant in water as the solvent. Yeah. Okay. Let's go through these. We're going to go through these 5 different techniques: magnetic separation, gravity and decanting, sieving, filtration, and centrifugation. Firstly, magnetic separation. As the name might suggest, what does the word to separate mean? Right, to break apart. Yeah? Cool. So what does something that is magnetic mean? Right. Metals and substances that are attracted to a magnetic field. Yeah? So those substances that can stick onto a fridge, for example. So magnetic separation is a method in which we use a magnet to extract the components that attract to a magnetic field. So an example of that here is, say, iron filings within sand. So the sand itself is non-magnetic, not attracted to a magnetic field. The iron in that, it's known as a ferromagnetic substance attracted to a magnetic field, can be drawn out from the magnet. It's useful, so its usefulness, this type of technique, particularly in mining, recycling, biotechnology. Yeah? Mining, because we might be separating those magnetic components, those metals, out of crushed rock. Right? So rock, typically non-magnetic, we might want to take that. Recycling, we might be looking at cars, right? Giant magnets to crush and pull the components, magnetic components, out of cars, and then separate those further. Gravity separation and decanting. Gravity means, right, attraction according to gravity, so pulling down, that downwards force that we experience because of Earth. So this is useful for suspensions. Remember, suspensions are particles that are dispersed within a solvent that are insoluble. And what happens typically with those substances is that they will be drawn down to the bottom. Yeah? If they're more dense than water, they'll be drawn to the bottom of the container. If they're less dense than water, they will rise. So like in the sense of example, sand will deposit to the bottom. Oil, less dense than water, will become floating at the top. To decant, right, is the second part of that process. Decanting is the pouring off. So often this is done with very old wine. Whose parents drink wine? Yeah? Do they have really old wines that they open? When they open something old, typically very valuable, is they'll use a particular glass container. Have you seen them do that?
The exact same one.
It's the same wine glasses all the time? Yeah? So there's this particular, sometimes beautiful glassware called decanters. And what happens is you take a very old bottle, often there'll be sediment. So little bits of the grape skins or little bits of oxidized material from the wine build up over time, right? And it doesn't taste very nice. The rest of the wine, delicious, right? So you pour that into a decanter. And so it's a way of separating that sediment, the bit that deposits out from the wine. So gravity separation separates by density insoluble substance, settles to the bottom of the container. Decant means to pour off. So there's our example, right, in the video shown. Yeah, so we can see that the water here, let's get my laser pointer. Yeah, the water here, we're pouring off the water and trying to retain the sediment behind.
If the morning sand would be there, would the water be cloudy from the sand?
If allowed to settle enough, then the water should be clear. If not, then we might use different techniques. Yeah? If it's mixed, then it's cloudy. If it's allowed to settle, the water should be clear. Here's some examples. Separating oil and water, as we talked about. Oil is immiscible, right? Slightly different definitions of soluble. And we might do this as a demonstration, right? You can make this at home using different densities. And right, I've put the link to this PowerPoint in our OneNote. If you click on the little Easter egg, it shows how you can make this at home. Yeah? It's this interesting word called immiscible. Immiscible is a bit different because we're talking about liquids. But immiscible is when I've got a liquid solute that won't dissolve. And so immiscible means we see the separation of layers between two liquids. So it's different liquids resulting in these different densities of water. Yes.
Like, is this kind of like a tarot viscosity?
Yeah. Viscosity relates to density.
Yeah.
Viscosity is the ability of flow or resistance to flow. So honey is really viscous. Honey is also rather dense with the amount of sugar that's in it. Okay. Another example is that fresh milk, not the milk you buy from the supermarket. Fresh milk is unhomogenized. Homo means the same. So homogenized means that the fat in the milk is distributed throughout the milk. And we achieve that through shaking it. Yeah? So you can get unhomogenized milk, which is when the cream separates from the rest of the milk, from the whey. Yeah? And so we can scoop that cream off, or we can filter the cream out and have the rest of the milk. And that's how you get lower fat milk, is you take fresh milk and you skim it off. So skim milk is skimming the fat off the top. Here is a traditional way. This is called Yandying. It's a traditional separation technique. The Yankin, I'm going to do my best to pronounce this. Yandying Thajara Aboriginal people in northwestern South Australia relied heavily on mulga seeds as a food source. Seeds would be separated from their pods through threshing and rubbing and then yandying to separate from their pod fragments. So this is a way of gravity separation of two different solids. Seeds taken, baked in hot sand ashes requiring additional yandying process to remove the sand. Finally, the seeds would be ground and moistened into paste for consumption. So this, what we're doing is we're taking this yandying bowl and essentially shaking it, and the denser substances go to the bottom, the less dense substances eventually rise to the top. Here's another gravity separation technique called winnowing, common across many, not just Indigenous Australians, but many Indigenous cultures across the world. It's a way of separating chaff. Chaff is the outside coating, or like the pod almost, to the grain underneath. So the chaff, there's a biblical quote about separating the chaff from the wheat. The wheat, the seed, is what's valuable. The chaff is what you throw away. Can you eat the chaff? The chaff is like insoluble fiber. You can eat it, but your body doesn't digest it well. Yeah? What you can do is it's important as part of your digestion to have some insoluble fiber, and that keeps you regular. So, have you heard of Metamucil before? Metamucil, if you're constipated, you'll take Metamucil, which is made from psyllium, which is a grain, the husk or the chaff of a psyllium grain, ground into a powder, and that psyllium husk, the insoluble fiber, helps to relax your stools and stops you from being constipated. Yeah? It's called psyllium husk. Okay, the third technique. So we've gone through magnetic separation, gravity separation, and decanting. Lastly, sieving. Sieving is similar, but this is where it's a bit like filtering. So we do this with pasta. You might be draining your tins or your beans, or in this case, chickpeas, right? So the sieve, the mesh retains the solid substance while the liquid is able to drain through. Yep. Sifting still two solids. Sifting, sieving, very related. Yeah? You can call it sifting or sieving. Yeah. So if I had a mixture of sand and gravel, had a sieve, yeah, sieve, a sieve is the device, sifting is the process, or sieving, sifting, same.
No.
Stabby thing, the sieve is a mesh, it's a filter. Okay, so we can see, right? A couple more slides and then we're finished for today. So if I had a mixture of sand and gravel, had a fine mesh, the sand is able to go through and I retain the gravel. Yeah, and then I can use the sand or the gravel in the way I need to. Yeah. Same idea. Sieving is the process. Filtration. Yeah. Related, similar to sieving. Often this is, but I'd use a filter instead of a sieve if the particle size is really small. So it's essentially a finer grained mesh or using paper or something, right? So it's closely bound, woven together material. 2 more minutes. Yeah. Paper, cloth, something that is porous. We want the liquid to go through, leaving the solid substance behind. Like filtering coffee. So the coffee grounds, the insoluble coffee grounds are retained by the filter. The dissolved coffee components are able to filter through. Grinded beans, yeah. So you mix that with water, some of it is still insoluble. So hot water, you pour that through a filter. The grounds are kept behind. The soluble components go through. Last technique, centrifugation, is another type of gravity separation sped up, right? Sped up through spinning.
They use this to separate the plasma.
Yep, and that's my example here. So your blood is a suspension of plasma and red blood cells and other components. There's some protein and other bits and pieces in there as well. So if we spin that really fast, the plasma, the liquid component, the solvent, separates out, leaving the other components in separate layers. Quite quickly. I don't know off the top of my head.
Okay. 5,600.
Yeah, so thousands of revolutions per minute. Really important in medical laboratories, right? Because we can extract those components, right? Some people aren't able to give full blood when they donate blood, so they can donate plasma and the remaining components can be separated and put back into the person's body. Or just separated and then they extract the necessary names. All right. Last slide for today. So of those techniques, the 5 techniques we've explored, thank you. Of those techniques, how we determine is based off these steps. We identify the components of the mixture, identify the properties. For example, if it's magnetic, we're going to be using magnetic separation. Based off the properties of the substances they're in, we choose the most appropriate technique. Plan the experiment, right? So there's design involved. Conduct and then evaluate our results. Leave it there for today.